Welcome back, fellow mathematicians. You are back with Miss Ledbetter, and I am so excited. We are ready to do some more math. Today we're going to look at simplifying square root numbers to its simplest form, and you need to be taking notes in your interactive notebook on page 26. The first thing that we're going to look at is the list of perfect squares. This is a list from 1 through 30, and the perfect squares are any number that can multiply by itself results with a perfect square. So for example, 2 times 2 equals 4, so 4 is a perfect square number because it can be two of the same number multiplied together will result in a perfect square number. So these are the list of perfect squares. I highly recommend memorizing through 1 through 20, all of those facts. Just because it's a simple time saver whenever you get to questions on your ACT, SAT test questions or college prep questions. It just makes your life easier. If you already have these numbers known and you can automatically tell the square root of 289 is 17, you can move on with life to more complicated issues. So it's just a good practice just to have these numbers. It helps your life when you get to further more complicated things. So I definitely recommend 1 through 20. If you don't have these numbers memorized, and at least probably 21 through 30, you probably would like to write these numbers down in your notebook so that you have them in front of you, because we will continue referring back to this list of numbers continually, as well as in the following lessons as well. So for example, if I wanted to take the square root of 100, I know that the square root of 100 would be 10, because 10 times 10 is 100. And also the square root of 4 is 2, because 2 times 2 is 2, or 2 times 2 is 4. So then if I wanted to put that together, I could take the square root of 400 is equal to 20. And I know that not only because 400 is a perfect square, so I know my list of perfect square numbers, there is also a rule that says the square root of a product of numbers is equal to the product of each of those square roots. So if you can take a number and split it apart between its two factors, then take the square root of each of those two numbers is the same thing as if you took the square root of the original number itself. So I know that the square root of 400 is the same thing as saying the square root of 4 times the square root of 100. And I know the square root of 4 is 2, and I know the square root of 100 is 10, and 2 times 10 gives me 20. So the square root of 400 is 20. So we can use that to work with other non-perfect square roots, such as the square root of 18 or the square root of 80. So the square root of 18, I could simplify, or I could factor the 18 to be 9 times 2. So if I take the square root of 9 times the square root of 2, that's the same thing as the square root of 18. I know the square root of 9 is 3. The square root of 2 is not a perfect square, so we're going to leave it as the square root form rather than taking the nasty hairy decimal. So the square root of 18 is 3 square roots of 2. That is its simplest form. And then 80, I could simplify that to be the square root of 16 times the square root of 5. And I know the square root of 16 is 4. And the square root of 5 is a decimal, so I will leave that as the square root of 5. So the square root of 80 is 4 square roots of 5. So then we can use the same principle whenever we get to bigger, more complex numbers, such as the square root of 294. And there's a couple of rules of thought here for your strategy on how to find these perfect square numbers. What you can do is go through the list of perfect squares and just start dividing by each of those perfect squares. So 294 divided by 4 gives you a decimal. 294 divided by 9 is a number, so you could use that, or just simply start dividing and look for those perfect squares. So the goal is to find any perfect square factors. So if I just start listing all of the factors of 294, all the ways that I can divide 294, well, I could do 1 times 294, or I could do 2 times 147, or I could do 3 times 98, and then 4 doesn't work. 294 divided by 4 doesn't work. 294 divided by 5, obviously, that's not going to work. 294 divided by 6 does give me a decimal number, and that is my perfect square answer. So I could change or factor the 294 to be the square root of 49 times the square root of 6. I know the square root of 49 is 7, so that would be 7 square roots of 6 for my simplest form for my square root. And then again, if we look at, again, more complex numbers, so looking even bigger numbers like the square root of 648, again, continue going on down the list of your perfect squares. So 648 divided by 4, 648 divided by 9, yada, yada, so on and so forth. Or just simply start dividing all of the ways that you can divide 648. So I could do 1 times 648. That is not a perfect square. Or I could do 2 times 324. And if you have the numbers 1 through 20 memorized, you know that 324 is a perfect square. That's actually the 18 squared. So I could factor 648 to be the square root of 324 times the square root of 2. And I know that the 324 is 18 square roots of 2. Or if you continued going down the list of your perfect square factors, the first thing that I did is I started dividing both those for perfect squares. 648 divided by 4 gives me a decimal, or is 162, which is probably still going to be able to divide by something else. So if I continue down the list, 648 divided by 9 is 72. And I know that 72 is also can be factored. I know there's also a 9 in the 72, so that would be the same thing as saying the square root of 9 times the square root of 9 times the square root of 8, because 72 is 9 times 8. Well, then the square root of 8 would be the same thing as 2 times 4, so then that would be the square root of 9 times the square root of 9 times the square root of 4 times the square root of 2. I know that 9 times the square root of 9 is 3, square root of 9 is 3, square root of 4 is 2, and then a square root of 2 left over. So 3 times 3 is 9, times 2 is 18. Still gives me the same answer that I had before. So a couple of different ways that you could do that, just depending on how your brain works. And if you're, just as long as you are looking for those perfect square factors, that's the goal, to find the perfect squares. And keep multiplying, keep factoring until you don't have any other perfect squares left. So then I know the next question that is on your brain is, well, what happens whenever we try to take the square root of a negative number? And I'm so glad that you asked that, because that's the next thing we're going to look at. Anytime that you try to take the square root of a negative, that would mean that you would have to have the same number times itself to equal a negative value, which is not possible. That doesn't exist in our natural world, the real world. So that's when we get into this imaginary number system, which is signified or represented by the letter I. So the imaginary number comes up anytime that you try to take the square root of a negative, because any number times itself will never result in a negative, because a positive number times itself, a positive times a positive, is positive, or a negative number times itself, negative times negative, is still positive. So there's no possible way to get a negative square root number. So we introduce this imaginary number and call it the letter I. So, for example, the square root of a negative 2 could be factored out to be the square root of a negative 1 times the square root of 2, and the square root of negative 1 is I, so that becomes I square root of 2. Or with your perfect squares, the square root of a negative 4 would be a negative 1 times 4, and negative 1 is I, 4 is 2, so 2 times I would be the result there. And also because the square root of a negative 1 is I, and if I tried to square that, anytime you square a square root, just cancels itself out. So then I squared is equal to negative 1 itself. So if we look at a couple of examples here, 5 times the square root of 121, well, obviously you know that 121 is a perfect square, so that would be the same thing as saying 5 times the square root of a negative 1, which is I, times the square root of 121, which we know that is 11, so that becomes 5 times I times 11, which is 55I as our answer, with nothing left underneath the square root, because 121 is a perfect square. and we just simplify the negative by using the letter I. Then we look at the square root of a negative 63 being divided by 3. Notice how dividing by 3 is not underneath the square root. That is important. So I'm not taking 63 divided by 3. I'm taking the square root of negative 63 divided by 3. So I have to simplify the square root of 63 first. Well, I know that the square root of 63 would be the same thing as the square root of negative 1, but I can take the square root of 9 times the square root of 7, all of that being divided by 3. I know the square root of a negative 1 is I know the square root of 9 is 3, and the square root of 7 is a nasty hairy decimal, so I'm going to leave that as the square root of 7, all of that being divided by 3. Well, if I multiply and I divide by the same value, the 3 divided by 3 is going to cancel because I am multiplying everything. If I multiply and divide by the same thing, then that would result in 1. So this would have a final answer of I square root of 7. So then now it's your turn. Here are a couple of examples for you to work for yourself. So if you want to pause the video for a second so that you can work through those problems, make sure that you understand. You will have a quiz in class, so make sure that you are taking good notes, that you can justify each of these answers, because I will give you the answers, but you still need to be able to justify how did you get those answers. So hopefully you've given yourself some time to work it out. The square root of 54 is 3 square root of 6. The square root of 384 should be the 8 square roots of 6. 2 times the negative square root of 36 would be 12i, because 36 is a perfect square. And then the square root of a negative 96, not a perfect square, would be 4i square roots of 6 left over. And that is your lesson for today. Thanks so much for watching and participating, and I hope you have a great day. I'll see you next time.